This is a solution video for Tutorial 9, Project 1A. Of course, in the getting started steps, you need to download this workbook, rename it with your name and a 2, and of course, put your name here. Jumping to loan analysis, let's do project step number 1, where they ask that we put the payment function in D12. So I'm going to type equal PMT, and then we'll take a look at what PMT wants. It wants the rate, NPER, number of periods, the present value, and in some cases it's optional. You might need the future value and or the type. So the rate is 5%, but that's needed to be divided by 12, and they've already done that, so we'll just click on the monthly interest rate. Comma. How many periods? Well, it's 5 years. We might need to multiply that by 12, but they've already done it, so we'll just click on the 60. And what's the present value? This is the money the bank handed you, so it's a positive value. We'll click on that, and basically that's it. The other two parameters are optional. If you want, you could click through and type a 0 for the future value. And the type is 0 at the end of the period, and that's the default, or 1 at the beginning of the period. So typically on loans, you're making the payment at the end of the period. So you could put 00, or you don't have to fill those in at all. The payment will come in negative because it's cash leaving your pocket when you make that payment. Now we'll move on to instruction 2, which in cell E7, they want to calculate the monthly interest rate. So I think the assumption here is I want to get this loan amount for this period, and I can afford that payment. So what would the interest rate need to be to make that happen? So we have a function for that called rate, and it wants some of the same parameters, which is how many periods are we looking at. So in this case it's 84, it's 7 times 12. And then we want to know, well, what is the payment? So it's 7,500, negative 7,500, it's leaving our pocket. And the present value is, we have 450,000 today that the bank loaned us. And again, optional, future value, type, and the guess. If we needed to go there, we'll just hit 0 and we'll hit enter, and there we get 0.84% is the monthly interest rate. Then of course we'll take that times 12 to get the annual interest rate. So instruction 3, different scenario. I know that I can afford a $10,000 a month payment. I'm doing it for 84 periods at 5%. How much money can I get given those loan parameters? So in this case, we're going to use the PV, present value formula, and it asks for the same information, which is our monthly interest rate and our monthly number of periods, 84. Remember, you got to keep all of your parameters in the same time frame, so whether it's yearly, monthly, quarterly. Finally, what is my payment? It's the negative 10,000, and we'll go ahead and close this up and not fill in the future value or the type. And that's the loan I can get for that period, that interest rate. Of course, similar parameters. Notice it's a much smaller loan when the interest rate's 10.13%. So instruction 4, now we want to calculate the period. So we have $1 million loan at 6% interest rate. We're paying it off at $10,000 a month. So how many months would it take to pay that off? So the formula we're going to use for that is NPER. So the fact that our rate is 0.5% on a monthly basis, 6% for the year, divide that by 12, we get 0.5. Our payment is the 10,000, and our present value is the million. And again, we don't need to fill in the optional parameters, and that'll tell us we need 139 months to pay off at 10,000 a month, $1 million loan that has a 6% interest rate. Moving on to instruction 5, has us go to the amortization sheet, and in cell C17 we want to calculate the cum interest for a 1-year period. So first let's understand the sheet a little bit. Looks like we're getting a loan for $250, 5% interest for 5 years. Here's our payment, and we're starting January 2nd of 2017. So after 12 months, basically, how much interest will we have paid? So we have a function, cum IPMT, returns the cumulative interest rate between two periods. So we're going to have to define the starting ending period. So in this case, it's asking for the rate, and we want to keep everything to a same time period. So we'll go monthly. So there's our monthly interest rate. And how many periods? Well, we need monthly periods, and so there's 60 of them. And then finally, what's the present value of the loan? It's a positive number, 250, that the bank just handed us. And what's our start period? Well, it's month 1, comma. The ending period is month 12. And notice the type isn't optional this time. And so we are going to go 0 at the end of the period. And so that will be the cum interest payment. Now the way they have this set up, we can leave, oh, no we can't. We're going to copy this formula across. So every one of the cells up here, the purple, the blue, and the red, need to be absolute. So I'll hit F4 on my keyboard for that guy, for the MPER, and for the present value. But the starting ending period I do want to change because I want it to go from 13 to 24, 25 to 36. So I'll hit enter, and I think I can drag that across and get the right answer. Instruction 6 tells us to use the error checking function for cell H17. So if you go to formulas, there's a group called formula auditing, and one of the buttons in that is error checking. So I can click on that, ... and it'll run through your formulas, and any that have errors, it will grab it. So it notices this error, and then it gives us a description. The formula contains unrecognized text. So SUMM is just a misspelling. So we'll edit the formula in the formula bar, take out the M, and hit OK. We can resume if there were any others, which there aren't, and we're done. In number 7, we want to do the same thing here, except it's going to be cum principal. So you type equals CUM, and not I payment, which is the interest, but it's the prince. And the rate is going to be the same, 0.42%. I will absolute it right away. The present value, or no, MPER, number of periods, is 60, which I will absolute right away. Present value is 250, which I absolute right away. My starting period is 1. I don't want to absolute that. And the 12. And again, the type is not optional, so we'll type a 0, put enter. There's our cum principal. And then they already have a formula that takes the loan amount and subtracts the yearly principal. And we can now drag that across. And so, of course, if you add up the principal for those time periods, it equals 250, which is the loan amount. Moving on to instruction 8, we're going to fill out this amortization schedule, which basically keeps track of our ending balance as we slowly pay off the loan through the 60 payments. Right here, we're going to calculate the principal that's made in our, the principal that we pay in our first payment. Several ways to do this, but they're having us use the PPMT function, which returns the payment on the principal for a given investment period based on a periodic constant payments. So PPMT, the things it wants are the things that we're hopefully becoming familiar with. One is our interest rate, so we got to do it monthly because our payment's monthly. The period, so that's what PPMT does, is if you give me a period, whether it's period 1, 2, 3, 4, whatever, I will tell you how much principal is being paid on the payment that was made for that period. So in this case, it's period 1. Now, of course, I don't want to type the 1. I will select it. I will leave that not absolute, a relative. So as I drag it down, it'll be period 2, period 3, period 4. And now that I said that, I realize D7 should be absolute. So there's our period, comma, and then of course, how many payments? Well, there's 60 of them, so F4, lock that. Present value of the loan is 250. Make sure you grab the 250 up here and not this guy, because this beginning balance is going to change as you drag it down. F4, and then of course everything's optional, future value and type. So we'll close that up and hit enter, and that's our principal in period 1. At the end of that instruction, it asks us to copy it down, so I'll grab the autofill handle and double click, and you can see the amount of principal we pay goes up all the time. And now I suspect instruction 9, we're going to go to F23 and calculate the interest. Several ways to do it, but they want us to use the I payment function, equal IPMT. Same information. What's your rate? 0.42% per month. Lock that. What period am I calculating the interest on? The first one. Don't lock it because we want it to calculate the second, the third, and the fourth as we copy the formula down. How many periods are there? Well, there's 60. Lock that. And then what's the present value of the loan? 250. Absolute. Close it up. I don't need to fill out the future value and type. Hit enter. And now I'll double click and you'll see that our interest goes down a little bit every payment until finally you get at the very end. And of course, you know you've done these formulas right if the balance at the end of period 60 is 0. Of course, because we have 60 periods in this loan. So that's it. Now, of course, they filled in a few of the formulas. You may want to study those, but I'm taking C23 right here and subtracting the amount we paid for the principal. That's my ending balance. And then, of course, in this cell, the beginning balance for period 2 is the ending balance for period 1. And they've already filled out the cum interest, F23, and then right here, they're just taking the one above it and adding the one for that month. And that formula you can just keep dragging down. Saying take the one above me, add it to the one for the current period, and that's how they're getting their cum interest. I could have also used their cum IPMT formula that we did up above. I can use that in the same location. Anywho's, what are we on? Let's go to number 10, which is the depreciation worksheet. And in cell C12, we're going to calculate the yearly depreciation on what looks to be a fleet of vehicles. So we have 125,000. They last for 7 years, and the salvage value at the end of that time is 17,500. So I want to know what this yearly depreciation is. We're going to use a straight line depreciation, which is SLN, and that's easy to use as long as you have all the information, which is the cost, 125. The salvage value is going to be 17.5, and for the life it's 7. Cover period is 7 years. So you close that up, and I suspect we will want to copy that across. So we need to absolute those values because, of course, those 3 cells aren't going to move on us. So we'll hit enter. We'll copy without formatting. So we'll drag that across. We can hit this fill without formatting. And because it's straight line, it's the same value all the way across. So now we move on to instruction 11, where we're going to calculate the depreciation again, but with a different function. We're going to use the declining balance depreciation. So we will hit DB, hit parentheses, and ask similar information. What's the cost? 125. I'm going to lock that. Push the salvage value, 17.5. We'll absolute that. And what's the life? It's 7 years. But because now this one changes depending on the period that we're looking at, there's another parameter called period. So in this case, we'll just put in the 1, and we don't want to absolute that. And I see that I didn't absolute the D6 either. So C19, the 1, we will leave relative. We won't deal with the month. It's just we're dealing with the years in this case. So hit enter, and that gives us the depreciation in month or year 1. But now when I drag that across, it slowly changes over time. It's a declining balance. In instruction 12, they want us to take a look at the problem with D21. And just to have some practice, they're saying use, again, in formulas, formula auditing, there's trace precedence and trace dependence. So who uses me, right? So when I click on trace dependence, it says who uses the value that's in this cell, and the answer is, well, the cell right below me. Trace precedence is who do I use? How do I calculate my formula? And so that's the blue arrow saying I'm using the value up here, and I'm using the value in cell B21, which of course is text, and so that's a problem. So we want to fix that formula. I'm going to remove the arrows right now because they're in my way. So you hit the remove arrow button. Now I can double click and go not B21, it's C21. So I hit that, hit enter, and now that formula is correct and I can drag it across. Notice the difference between the two types of depreciation. The depreciated asset value on the straight line, it depreciates the same every time. The depreciated on the declining balance, it's instead of 109, it's 94, so you do much more at the beginning. and then it slowly gets to be less and less towards the end. Up here it's 15 each month or year, and down here we're 7, 9, 13. At the end though, the asset value is close to the same, $20 difference. Moving on to instruction 13, we're now going to go to the income statement, and they want to project the revenues using a growth trend interpolation for the classroom fees. So basically, we have a number in 2017, we know what it's going to be in 2021 or something we're anticipating, and now we just want to fill between those two values. That's why it's interpolation versus down here we're going to do an extrapolation where we only know one end and we want to increase it by a certain percentage. So here we're going between 2 points. So we'll select those, go to the home ribbon, and here's fill, and we're going to fill a series, and it wants a growth trend. And of course you have to select the range that we're interpolating between, click on growth and trend and hit OK. And because it's growth, it's going to, here it's 70, here it's more than 70, it's 88, and here it's even more than 88, it's close to 100 and something, right? So the difference between each time period is a little bit more each time. That's a growth trend. And it calculated that based on our first period and our last period. So instruction 14, we want to do something similar to an interpolation between two values, but it's a linear trend. So we want it to be the same amount between each time period. So I'll just select that, and it's basically the same, fill series. Type is linear, it's a trend, you want to click on that trend, although to be honest with you, I think it works without clicking the trend. But anywho's, you hit that, hit OK, and now we got an even amount increase between each of the two endpoints. For instruction 15, we're projecting the expenses, but again, we only have one data point, so we're going to extrapolate that value out to the future. And so we're going to fill the series. It's a growth trend, or growth, I shouldn't call it a trend. We're going to leave that unchecked and give it a step value. Basically, we want to increase by 7%, 1.07, every time period, so in this case every year. We're not putting in a stop value, but I do want to make sure I have my cells selected before I run this, so I hit OK. And in essence, it just did this cell times 1.07 all the way across without actually putting in that formula. So that's extrapolating this payroll expense increasing 7% per year. Instruction 16, we're going to go to the rate of return, and we're going to calculate the net present value of a particular investment. So basically what this looks like is we're spending $250,000. It's a negative number, it's coming out of our pocket. But in return for that, this is the expected series of payments we're going to get for the next 6 years. And what we're trying to figure out is it worth it? Should I spend that money if this is what I'm going to get back? Our desired rate of return is 7.5%. So in 15, we're going to use the NPV function, net present value. What it's basically doing is taking a series of payments and bringing it back to a value to today's point. And then I can look at that number and compare it to the amount that I'm spending. So it's not a hard function to use, in that it just says, well, what is your desired rate of return? What interest rate are we dealing with? We're dealing with yearly things, and so we'll just click on 7.5% per year. We don't have to change it, comma, and then it says, well, what are your series of payments over the time period? And so we will just select D7 through D12, hit enter, and so basically there's the present value of that series of payments. And then in subpoint B, we're going to take that value and add to it. And the reason it's plus is because this is already negative. So plus D6, you hit enter. And basically the fact that that's a positive number is a good thing. That says, yeah, it's worth it to spend that $250 to receive that series of payments, because you end up with a positive value at the end. If this is 0, then you're breaking even, and if it's negative, well then, yeah, don't spend the $250 because it's not worth it. Finally, instruction 17 is asking to calculate the internal rate of return, and that's basically what would that interest rate need to be for this net present value to be 0, to break even. So we will type equal IRR, parenthesis, And it goes, well, what are your values? And in this case, we do select the 250, the amount of our investment, and all of our return payments. You close this up, we won't give it a guess value, and we hit enter, and it will do a calculation and say, all right, 8.1% is the point where net present value equals 0. In fact, we can test that by just putting 8.1% up here and see that it was close enough. It went to $32, not exactly 0, but this is probably 8.1 something, and we're not seeing all the digits. So I guess I could fix that. There you go. So that's the answer. If we put that answer up here, this would end up being 0. So I will convert that back to 7.5%. And then at this point, you should double check that your values look the same as the pictures in the instructions, and then submit to Sam for grading. And we're done.